Without further ado, please welcome on stage BricsCAD product owner Yang Yuli and members of his team. They will demonstrate the latest features and workflows in BricsCAD V21 that will help you leverage unlimited design capabilities in BricsCAD. So, Jan, welcome on stage.
Okay, thank you for the introduction, Arena. It was a really nice party, it seems. So hello, I'm Jan Jolly. I'm the technical team lead for BricsCAD Core, and I will be presenting this session. I'm joined on stage by Xian, the product specialist, who will be doing the demos. So one of the things that we always try to focus on is performance gain as well, of course. So for this, an example is improving processes. And we've made changes to the way we handle images. In earlier versions, when you were manipulating images, you only saw the outline of the image, while now, while you're editing, you still see the end result of what it will be. And this means, of course, that handling things will go a lot smoother and everything is much faster. We take away clicks, in fact. The image on the right here, you see it has a crop mask. While you're adjusting the crop mask, you get a preview of what the end result will be. So again, a performance gain there by speeding up actions. Another thing where we try to improve performance is eliminating downtime. For example, when you're loading in heavy files, trying to minimize this. One of the examples that we'll show here is Sketchup Import. Earlier, when we were importing Sketchup files, we always stitched the entire thing together. This could take quite a while, so we adjusted the process there a little bit. When importing a Sketchup file, we now import it as meshes. This means also that we keep the import as named blocks, and the render materials are now also imported correctly. Because it's a mesh, we of course needed to make improvements to the way we handle meshes. Xian is now showing in the properties panel, we have added a property. The smoothness property can be adjusted. You see she's here, the object that has been imported. She's changing some colors, changing some of the geometry, so to speak. Zooming in here and changing the smoothness property. So it gives you a lot of control over the object that has been imported. And let's go a little bit crazy even. Let's set the smoothness property to 0, to none, and pull out a point, and at the top we'll pull out another point, and then we'll switch on the smoothness again, and we've completely remodeled this imported thing in a couple of seconds. Okay, but at BricsCAD, we love our solids. So this is only a mesh now. Well, we simply convert it to a solid. And once you've done that, we have the direct modeling tools to further manipulate this object. There are other ways that we increase performance, the more obvious things, like moving some processes to a background thread. And examples of this is the XREF loading that we can now do in the background, but this will be demonstrated in the BIM demo. Loading of mask properties is also done in the background thread, and more and more. I'll continue now with an overview of commands that we adjusted. Either we introduced new commands, or we added functionality to existing commands. You see this 2D drawing. We want to change the color, but for some reason, the color doesn't change. But then we realize it's set by block. It's a mistake I often make, and I'm sure other people do as well. So instead of changing it by block, we change just the color of the layer, and then we use the new command, set by layer, to change everything on that layer in one go. We did the color here, but it can be, of course, any other property of the layer. That's a new command. We also continue improving existing commands, like the old and trusted copy command. We have a piece of furniture that we want to move in the other offices as well. Instead of having to copy it a couple of times, you can do it with one click by using the new array option to place the piece of furniture in all the offices at once. Now, this drawing is a drawing that we received from a contractor, and we don't really like the style because we have a house style. And we want to convert all these layers to our house style. Well, we have an example drawing that is set up just the way we like it. So let's import it. Using the new latrans command, it brings up a dialog. And in the dialog, you simply pick one of your example drawings. You then can do an automatic mapping of layers that match. And the layers that don't match, well, you map them manually. And once the mapping is to your liking, once again, you push translate, and this drawing looks exactly how we want it. Now, there are a couple of loose text elements in this drawing, and we don't like this. We want to group it together. So using the new command combine text, we make an mtext entity out of it. And once it's an mtext entity, we make, once more, the adjustments that we think are needed. And you will also see below the mtext entity that we now added, there's an arctext entity. Now, in V21, we don't yet have an arctext entity to add it. But if there is an arctext entity in there already, the properties now allow you to completely alter the arctext entity to your liking. Not only that, one of the things we really think are important is an open format and an exchange with other software, already shown by the import of the Sketchup file. But we added one important thing here is Dgn Export. Before we already had the import, well, we added the export now. And we also moved some things around. 3D PDF export was already available in Communicator, but we moved that down to BricsCAD, so it's available. There are a lot of other commands that we introduced or either altered. I'm not going into all of them because it would take us too far. But version control is an important one. It's a Git-like repository system allowing smoother working on the same drawing by multiple people. Again, this will be shown in the BIM demo. We've made improvement to the way we export layouts. We added a view broken command, a block icon command, and also when you're in your trial, you can set the license level to simulate, if I would buy a Lite license, what functionality will I have available? Well, you use the set license level command to set it to Lite, and then you can use the commands command, and this will list all the commands that are available for this license level. Okay? So that is a bit of a roundup of general changes that we made, and mostly 2D. Let's go into direct modeling now. Okay, let's go on. We made a couple of changes to the direct modeling. Again, this is a case of where we had existing commands, DM fillet and chamfer. They were already available in the quad, in the ribbon, and also in the menus. Well, we extended DM fillet by adding an option which allows you to set your fillet with the variable radius. And you will also see while Xian is doing the demo that the manipulator pops up, or pieces of the manipulator pops up. And this allows you also for much quicker editing of the geometry. You don't have to go through commands, but can do it very intuitively. We did the changes with fillet on that bracket model. Now, with the chamfer model, with the chamfer command, we will execute it on this model. For chamfer, we even added 5 new options. When making your chamfers, you have a plethora of options to choose from. You can say, do I want to set it constant or variable? Do I want to do it asymmetrical or symmetrical? And while doing it, you can set angles or distances. And how many distances you set or angles depends, of course, on which of these variants you've chosen. All right. So while Xian is finishing up this model, let me also already talk a little bit about the next part. So direct modeling, we keep improving, as I said before. We had already connected modeling in V21. We introduced it that on a move, you could say, OK, I want this object to keep the connection with the connecting solids or not. For V21, we made a couple of changes. You can choose in the Hotkey Assistance at the bottom, by pressing Control, you can switch between these two modes. And not only that, but it now also works when rotating. So Xian is rotating the roof, and you will see that the other walls automatically extended, so they still fit the roof. And by using Control, as I said, you can choose not to do it or to make the connection. Another L-connect and T-connect are other examples of commands that we improved further. We added an option to disconnect. So an existing connection, you can now break it. And it now also works on regions and planar surfaces. Now, you will say, OK, very well, this was a very simple model. But let's try it out on a little bit more complicated model, a more real-life model. And you can see, I want to note here that this is not a BIM model. They're just plain 3D solids. You see the roof that Xian is manipulating now. Under it are a couple of beams and also interior walls. While rotating the roof, we make some calculations. And once the calculations are done, you can rotate the roof about. And the beams, well, they will just follow along with the roof. And also the walls are automatically extended. And let me once more stress that we don't use BIM information for this. It's working on plain solids. OK, now here we also made changes when editing vertices. So Xian is moving this vertex around, and the default mode now is that it uses triangulation. So the moving is quite limited that you can do, but you can change the topology a little bit. But you can also have the option to freely move it and then completely alter the geometry. Those are the two new options that were added there. One more that we also won't show, but that we did make a lot of changes to is the push-pull. Before you could already, there was a setting, whether when you're push-pulling, if it subtracts from another solid or not. We made that once again in an option. So by pressing Control, you play around with it to your liking. And we also make changes to when editing cylindrical geometry. You can select your starting point dynamically. OK, that was it very quickly for my session. I will now introduce my colleague Wouter, who will take us through the parametric modeling part. Wouter, come on stage.
Okay, so thank you, Jan, for this nice introduction. So the parametric modeling engine of BricsCAD was developed in-house and makes driving 3D geometry and constraining very easy. The power of parametrics extends even further this year, because this year, from this strong foundation, we've actually engineered a better alternative to the dynamic blocks. We call them parametric blocks. They can be used in both 2D and 3D and allow users to actually define a block once and reuse it multiple times in many sizes and orientations. So let's have a look at this 2D floor plan of an office building. As Xian is showing now, each of these chairs just are consisting of 2D entities, so lines, polylines, and maybe also arcs. Let me remember you that 2 years ago, we released this amazing Blockify tool. It allows you to select 2D entities and convert them to block references in just one click. And now, after we created some block references, we also show a new amazing tool which actually automatically adds constraints to a 2D selection set. We call it Autoconstrain. So just in the flash, the seat of this chair has been parameterized. And when we open the parameters and constraints panel, we can actually alter the parameters of this chair. We can see the width of the chair, but we actually don't need it, so we put the expose property off. And the depth of the chair we are interested in, so we rename it to seat depth. You can see also we can change some values, and after closing the block, we are actually done, and we turned this regular block into a parametric one. So you can see in the properties panel, we can change the value of the seat depth parameter, or for one block or for multiple blocks at the same time. It is really easy and straightforward. However, not only 2D constraints can be used in parametric blocks. Let me remind you that the Blockify tool allows you to automatically search geometry patterns in your drawing and also convert them to associative arrays. So now Shiana is selecting a part of this table set, so just like the bottom 2 desks and chairs. And with just one click and using Blockify, the complete array is automatically detected. However, when having a look in the properties panel, we can actually see that arrays are quite complicated entities. So we have number of columns, number of rows, spacings, and so on. We actually don't want this. We want to make something more simple, so we can actually create a block around it to make it more simple. So we can choose the name, the conference set. We can also pick the insertion point. And as such, we converted this array into a regular block. Let's now use bedit to make it a parametric block. Again, in the parameters and constraints panel, we can define the essential parameters for this block. So actually, these are the parameters we need to control the behavior of our array. In this case, in fact, we only need one parameter, which is the number of persons. And this number of persons can be used in the expression for the columns of this array. Also, by changing this value, we can see whether we did a good job, but indeed, all looks very nice. We can change the value to 6, to 10, and so on. When closing the block, we have what we actually want. We have a parametric block with a single, simple parameter. Let's also see now what we can do with this block. As in essence, parametric blocks are just regular blocks with some metadata. We can use the familiar insert and block command to insert and to handle these blocks. This is also new for BricsCAD V21. So indeed, we can simply change the number of persons here in the properties panel, and that's exactly what we want. Actually, we are quite happy with this parametric block, and we would like to reuse it in some other projects. This is where the library panel comes into play. By a simple click on the plus icon, naming the block and choosing a file location, we can actually save this block to our library. It's really easy and straightforward. So we choose an insertion point of this block, and actually we are done. Now we can go to another project, for example, this floor plan of a much simpler office building. We can go to the library panel and just simply select this newly created block and insert it in this other project. Let's have a look what we did this year regarding 3D constraints. So last year we introduced the concept of geometry-driven constraints. This actually made it possible to select an angle or a distance in model space and use it in expressions of other constraints. It allowed users already to create quite complicated parametric behavior, but actually it was sometimes quite hard to decide which constraints to select, which ones not to use for geometry-driven constraints. So this year we actually made a big step forward by making it possible to turn any parameter to be geometry-driven. So it's actually quite hard to explain it, but let's just do it on a quite simple model of a 3D chair. So initially we started with just a plain model, but we use parameterize to automatically constrain this chair. So in just one click, the system has automatically created parameters for the chair. It also automatically saw that the bottom part of the chair has equal dimensions in all 3 directions. So as Shiana is showing now, we can create a size parameter for this bottom part. However, what is new here is that we can turn this size parameter to be geometry-driven. And after doing that, we can go back to model space and we can freely manipulate the chair while all parametric relations are nicely maintained. As a second step, we can also have a look at this parameter representing the back height of the chair, which we can set to be 2 times the size of the bottom part. And as such, we can actually manipulate any face of the chair while our design intent is maintained. All right, let's have a look at a bit more complicated example for this geometry-driven constraints. Here we have an assembly structure for a mechanical model, which contains 5 nozzles. And when we have a look at this small plate here, we can see in the parameters and constraints panel that we have actually a nozzle diameter, so a parameter which controls the size of the plate. So it means when you change the nozzle diameter, the size of the plate changes accordingly. However, BricsCAD V21 allows you to solve the inverse problem. If you know the size of the plate, you can also automatically compute the nozzle diameter. So by simply setting the size of the plate using push-pull, we can see that the nozzle diameter adjusts accordingly. Let us have a look at a last example of these geometry-driven parameters, namely for the movement of a nut. So when we zoom in a bit, we can see that we can actually move this nut, but when we move it, it will just be a simple translation, so it will just be shifted. Nothing special happens. However, we can see in the parameters and constraints panel that we have an angle parameter which we can enable, and this angle parameter is geometry-driven. So now, when we now move the nut, it actually nicely rotates. So I think it's a very explanatory example of how these geometry-driven parameters work. Finally, I'd like to note that this new feature does not only work on newly created models. It can also be used on models created with previous versions of BricsCAD. For example, this nice and complex kinematic model. When we simply turn all of the driving parameters to be geometry-driven, we can start freely moving the upper part of this model, and the system will automatically calculate the length of the legs. I think it's a very powerful feature, and I cannot wait to see how our users will use it in their kinematic parametric models. In today's computing environment, storage space and CPU power is almost unlimited. But that doesn't mean we need to waste it. At Bricsys, we are dedicated to deliver tools to help you create the most accurate data in the most compact form, making your DWGs easy to load and save, and also lightweight to store and share. These optimization tools make use of artificial intelligence and machine learning in order to organize the data in the most optimal form. So let's have a look at this roof truss, which is actually a part of the convention center model which will be used during our BIM session. This roof truss assembly consists of almost 500 plain 3D solids. So let's have a look at one of these I-beams and use the parameterize command to automatically constrain it. So in just a flash, the system has added these parameters and constraints automatically. We can now use the animate tool to help us visually associate each parameter with the model geometry. So actually, by animating, we can see what the effect of each parameter will be on the model dynamically. Okay, so now we have actually a parameterized beam. And let me now introduce one of our new drawing optimizations tools, which we call Parametric Blockify. When we select the I-beam, it will not only convert this parameterized solid into a parametric block, no, it will also analyze the entire search space, the entire model space, and look for solids which meet the requirements to be a parametric version of this I-beam. And in just 7 seconds, or a bit less even, we are done. So actually, 213 of these plain solids are actually identified to be a parametric version of the beam and are converted to parametric blocks. And when we zoom in to one of these beams, actually the quad also helps us to show that we have a parametric block. And when we go to the parameters section of the properties panel, we can just change some values, for example, the length of this I-beam. I think it's really powerful. All right, so during the previous part of this demo, we actually introduced the concept of parametric blocks, which drive both 2D and 3D geometry. So let me now introduce another property of this parametric blocks, which we call visibility states. So as you can see, each of these types of chairs consists of 2D geometry, arcs, lines, and polylines. And Xian is now copying and pasting each of these chairs to like an empty space and model space. Now we can actually convert these entities to a block. So we launch the block command, we choose a name, chair block, and in just one click, actually this geometry is converted to a block reference, to a newly created block definition. Let's now use bedit and launch the new visibility state command. Actually, it's possible to create a new visibility parameter with 3 different states, so 1 for each of the type of chairs. So we can call them simple, comfy, and complex. So for each of the types, we can create the state, give it a name, and select the entities that belong to the state. It's quite simple. And after doing that, it's actually easy to create these states. So actually, by just creating a new parameter, we are almost ready to turn this geometry in a new parametric block. So when we have the 3 states, we can see that they are a bit scattered over the place. So now Xian will actually move them on top of each other so that they are nicely stacked at the origin of this block editor. And after doing that, we're actually ready. So we actually turned the original regular block into a parametric one. So when we go back to model space and check the properties panel, we see that this block has now become a parametric one with 1 parameter, namely the type, which we can change to each of the 3 types of chairs. Actually, now we are ready to do some real magic with our new friend, Parametric Blockify. So let's launch Parametric Blockify and select this chair to be the input of the command. And now the command will automatically analyze the entire search space and actually replace sets of 2D geometry representing each of the type of chairs by a parametric block. And now we can select 1 or multiple of these blocks and simply change the state. So actually we organize the drawing in a much better way. I really think that this parametric blocks is really powerful and the sky is the limit in V21. Okay, let's go to the next part of this drawing optimization demo. Actually, some drawings during drafting or during a sequence of imports and exports between different file formats, small errors can sneak in your drawing. Actually, to show this, we actually use a quite exaggerated drawing to show what we can do for you. We actually introduced a new command, but first we see that this geometry is really a mess. When we go to the properties panel, we can see that the y-coordinates for this particular line are a bit off. So they are not exactly 10, they're just a bit around 10. So this is not optimal. Let's now use the new Optimize tool to see what we can do about it. You can see the control dialog of Optimize being launched. As a first step, we select the entities we want to optimize, and we can see we have several options, so we can choose what we exactly want to do. We can choose to close gaps, we can choose to rectify horizontal, vertical, or 45-degree lines, and we also have some tolerances. So mind when Xian is changing these values, the live preview is updated accordingly. As such, we know on beforehand what will happen after we do the optimization. So when we're happy with the values, we can press OK. And just as such, we can see that the drawing is now optimized, so the gaps are closed, all lines are nicely horizontal and vertical. And when we have again a look at the properties panel, we can now see that the y value of the start and end points of this line are nicely rounded to 10. So let's now have a look at a very specific use case of this new Optimize tool. Actually, Optimize turns out to be really handy when working with point clouds. Here you can see a drawing which actually originates from a projection of a point cloud into the 2D plane. However, we can see all lines are a bit off. They are not horizontal, they're not vertical. There are lots of gaps in there, so it's not really usable to work with. So for example, if you would have a BricsCAD BIM license, you maybe would like to use QuickDraw to start creating a 3D model from this drawing. However, we can see that actually the cursor fails to snap to these double lines, so we cannot do anything with it. Optimize to the rescue. Okay, now we can again select the entire drawing, change some values, and when doing it, we again see the selection set being updated live. And when we're happy with the values, we can choose to optimize. And in just one click, we can see most of the gaps are filled, and also the lines are nicely horizontal. Now we can actually make QuickDraw do its magic. We can snap to the lines and start creating a 3D BIM model. So point clouds to BIM, it's all possible in BricsCAD V21. So The number of drawings originating from scanning devices is increasing rapidly. But actually, typically, we see that these kind of drawings contain way too much detail to handle in a double precision CAD system like BricsCAD. For example, let's have a look at this scanned map. And when we hide some of the layers, we actually retain only one entity, so this polyline. Actually, this is a part of a lake, but a part of the boundary of a lake, which only spans 340 meters, but it contains more than 350,000 vertices. So it actually makes it very hard to handle. So see how hard it's to select it. And we will not even try to open the properties panel because it would take ages to process all of the data. Actually, this is horrible. So that's one of the reasons we introduced a new simplify command. Let's set up simplify, select this polyline, set some settings. So for example, the maximum change in angle, the maximum length. And in just 1 second, the line is optimized. And now we can actually go to the properties panel. And we see it's simplified from 350,000 vertices to only 450 vertices. But just as importantly, when we save the file, we see something more. So it's not only easy to manipulate this polyline. Also, after saving the file and having a look in the File Explorer, we can see that the file size has drastically reduced from 7.6 megabytes to only 4.6 megabytes. In the most CAD software packages, 2D drafting hasn't improved a lot over the past decades. Actually, at Bricsys, we want to keep innovating in the 2D space because our customers demand this level of innovation. So last year, we introduced the copy-guided command. It allows users to select a detail in some context, for example, a door in a wall, and then move it in a guided way to similar locations. For example, here, this wall with the same composition. So this year, we actually made a quite logical extension to copy-guided, which we called move-guided. So it allows users to select, again, the detail and move it to another location. So as you can see, it's not only moved, but also the wall at the original location is nicely healed. This maybe seems trivial, but it's not. Because if we would just simply select a door and delete it, we can see that nothing really happens. So it's just polylines, hatches, there's no magic there, no features, it's just plain 2D geometry. So Move Guided actually allows you to regenerate and heal these original locations in a very fast way. So again, here Shiana's remodeling some parts of the toilet area, so she's quite easily changing some doors at other locations. Let's now use Move Guided regarding this meeting room and office spaces. So we can see we have lots of windows in the outer wall. Actually, we don't want these much windows, so we can simply use Move Guided to select them and move them away out of the wall. We can see after doing this, the polylines and the hatches are nicely regenerated. So actually, it makes 2D drafting way easier. Oh, damn it. I just realized we made a small design mistake here in the toilets area. We actually have the women's toilet without a sink. Actually, I don't think it's acceptable. This would actually mean we have to undo all our work regarding the windows. Well, actually, in BricsCAD V21, it doesn't. We actually have recorded the history per entity. And when we go to the properties panel, we can select one entity and just go back the steps we need while maintaining what we did in the area with the windows. So I think it's a really powerful feature for BricsCAD V21. So that concludes my part of the presentation. Thank you for the attention.
Okay, Walter, well, thank you for the amazing presentation. I think it clearly shows how at Bricsys we continue innovating also in the 2D and the 3D environment, let's say. For the next part, I would like to introduce my colleague Andre, who will talk about our next iteration for the civil tools. Andre, take it away.
Thank you, Jan. So, version 21 brings many advanced tools for linear infrastructure modeling. And in this demo, we will show the conceptual design of a road and a bridge. So, we will start our demo with a site model. First, we'll create a surface, a thin surface from multiple files. And since this surface is very large, it's actually larger than our area, we'll first define the clip boundary to make this surface smaller and more performant. Then, to make this surface more realistic, to be better visual representative, we'll assign the raster image to the surface. And now we got really nice looking and proper site model for our further design. We'll continue our design with the alignments. Alignments are the objects used to precisely define the linear infrastructure. Alignments have horizontal, vertical, and 3D alignment. And in version 21, we have added support for the spirals and parabolas. So we have created alignment, picking the points, but it was automatically created also in 3D. So we have created 2D geometry, but it was projected to the surface, and also the vertical alignment, the design vertical alignment was created automatically using the accuracy factor setting. So if we now draw this vertical alignment in the profile view, you can see that we have actually two vertical alignments. First one, the cyan one, it represents the existing ground. So it's a projection of the horizontal alignments to the profile. And then we have also the design profile, which was created automatically using accuracy factor. And by changing this accuracy factor, we can specify how closely the profile fits the existing ground. So then we have switched to the manual mode, and we can do the manual edits to the profile. So we can remove, add PVI points. We can also do all the grip editing. And once this profile or vertical alignment is selected, you can see all the properties directly in the properties panel. So we can iterate through the PVI points and see the radius, the stations, the elevations, the grade values for each PVI separately. So now let's continue with another exciting functionality, which is called corridor. Corridor is a 3D model of linear infrastructure. It is defined with a template and the 3D alignment. First, we have created the corridor template elements. Basically, we had the polylines, the just simple polylines in the drawing, and we used corridor template element to convert those polylines into corridor template element. And after that, we'll attach the template elements to the template, to the corridor template, which will be later on used to build the corridor. So we can have several corridor templates in the drawing. We can attach many or multiple template elements also to the template. And once we have the templates ready, we can start the modeling the corridor. So first we select the 3D alignment. Then we select the corridor template. In our case, we'll have three different regions. So we'll start with the road, then the next region will be the bridge, and then again will be the road segment. So you can see the corridor is a real 3D geometry, not just the lines and polylines, but it's a basically 3D object. And So we will add now another region, so the bridge region to the existing corridor. So specify the start station, the end station, and the second region is added to the corridor. If you zoom closer, you can see this region have the holes, which is that precisely defines also such complex geometry as bridges. Now let's add the third region to the corridor from to the end of the corridor. If we select the corridor and switch to the properties panel, you can see that we have again many properties. We have the properties for each region like start station, end station. We have sampling interval and also visual styles. We can switch on or off different graphical representation of the corridor entity, and doing that we can really adapt this visual appearance of the corridor to our needs. We don't need meshes all the time, so in such cases we can just show the sections and the string lines. Let's continue now with the cut and fill slopes. We'd like to create the slope, the cut and fill embankments at the edges of the corridor. We can do that by first we have to extract the polylines from the corridor. Basically, we can extract also meshes and the solids and the boundaries from the corridor. Doing that, we get the native CAD entities like 3D polylines, meshes, solids. And then we can use those entities for different purposes. In our case, we'll create a grading from extracted 3D polylines. So, and now if we select the 3D alignment, so which defines the corridor, we get the grips, and by moving the grips, you can see the corridor updates in the real time, and it adapts to the new position. So we can do the horizontal changes and we can do the vertical changes of the corridor. So we have different grips to move the alignment geometry in horizontal or vertical direction. And you can see that terrain or thin surface is overlaying the corridor. So we would like to somehow incorporate this corridor into the existing ground. So to do that, we have to select the grading as the height boundary for the thin surface. So now also the cut slopes are visible. The only part we need to make visible is the corridor. So we have to extract the outer boundary of the corridor and use this outer boundary as a height boundary for the thin surface. Now we can turn on the corridor again, and if we look closer, you'll see that this road is nice and smooth, adapted with the existing ground. So once we make a corridor, then we can, let's say, put some additional objects on this corridor. Corridor defines the precise geometry of the linear infrastructure. So we have used the parametric technology, which is inside of BricsCAD, to add safety barriers, to add bridge pillars, or to add bridge abutments to the model. And by doing this, we make our model really visual correct, and this model can be used for different purposes then. So this was the main functionality, or just part of the functionality of new civil tools inside of BricsCAD. So I would like to kindly invite you to watch our in-depth sessions, and where we would like to show also some other attractive and useful functionality like earthworks, interoperability, API examples, and so on. Thank you.
Okay, thanks, Andre, for this in-depth, no, not the in-depth session that will come, but for this overview of what we changed for civil this year. As a final part for BricsCAD Core, I would like to introduce Piet Lelieur, the product manager for point clouds, who will walk us through this. Piet?
Okay, thank you, Jan. So the new point cloud features for the V21 follow the general BricsCAD rules for licenses. That means that in Lite you will be able to view point clouds that has been attached in a drawing that has been made with a higher license. In Pro, you can pre-process, crop, align, and color point clouds. And in BIM, you can generate building elements based on surfaces and solids, and you can create floor plans. We use three principles to develop the new point cloud features. First, in Pro, we want point clouds to be high performant, fast and easy to manipulate and to navigate. So the import is more than 5 times faster. We added new file formats, and bubble views are created during import. Secondly, for BIM, we want to create 3D geometry with smart algorithms. The geometry follows the reality as it is, even when it's skewed, and we give feedback on the deviations. Finally, we allow BIM users to create 2D floor plans based on point clouds. We can create 2D lines and raster images that can be combined with regular BIM models. So, Xian just showed us how to attach and align a point cloud and crop it with the Pro features. Now we can automatically detect volume sections for each floor with the detect floor command. These volume sections can be used to generate 2D drawings with the background raster image in the project section command. You can adjust a series of parameters to improve the final result. A lot of the performance improvements in point clouds were made by using background processing and multi-threading. And we added a progress bar to give feedback to the user. As you will see in the final result, we get a high-resolution raster image and lines. And as seen before in this demo, these lines can be used with the new optimize command to start a 2D floor plan or a 2D section. Also in BIM, we can generate 3D geometry. This can be done in our new bubble viewer. It's a separate window that has 3 viewing modes. The first one is the natural color. This is a grayscale scan. The second visual mode is the normal vector mode. The colors give information on the direction of the surfaces. These colors are the same as used for the axis in the model view. That means that blue colors are surfaces that are perpendicular to the z-axis, and red and green perpendicular to the x and y-axis. And finally, we have the depth map. This gives information on the distance of a point to the scan position. To create 3D geometry, we can run the fit planner command inside the bubble viewer. The cursor will give feedback to the user on the direction of the surface. And if we select the surface, we get a preview both in bubble view and in model view. You can create rectangular shapes, but you can also create contour shapes. It's very fast because it only uses the points in this scan position. But the fit planner command can also be used in the model view. It takes more time, but it has two advantages. It can be used in unstructured point clouds, that are point clouds that don't have information on scan positions, and it can find thickness of walls and slabs. That's because it's searching the complete point cloud. The geometry created with this fit planner command can be used with the improved L and T connection that also work on surfaces. With the combination of the classic BIM workflow and the new features in V21, we can generate high-quality graphical images that still can be annotated as normal BIM sections. As you can see in this example of a historic church where we've added a modern elevator. We use the point cloud to generate the background, and the BIM section can still be annotated with BIM tags and spot elevation levels. And finally, you can expect a new feature that you will deliver during the V21 lifecycle, a VR viewer that can be launched directly from within BricsCAD. You can use a VR headset to navigate and examine a point cloud and use tools like flashlight to see even more details. We really think these new features will help you as a user in handling these huge data sets. So that's all for point clouds. Thank you.
Okay, so that wraps up the session. I would like to thank everybody who has been presenting, Piet, André, Wouter, and of course, Xian, who has been walking us through all these new features. I would like especially to thank the entire team who have been working behind the scenes very hard, and I'm sure you agree has been quite a special year. And I would like to thank you, the audience, for watching this. And be sure to stay tuned, because with the BIM, the mechanical and the 24/7 sessions, we have a lot more goodies coming. I'm signing off, and see you next time.